Hi, I'm Clara Fernandez-Vara. I'm one of the faculty members here at the Game Center. And it is my pleasure to introduce you to Ken Perlin, who is a faculty member here at NYU. His office is right here. But he is actually way, way cooler than, he looks cool, but he's really cool. So if I can bring up my notes, I can tell you the official title. Ken is professor in the Department of Computer Science here at NYU. He's the director of the Media Research Lab. And his research interests are computer graphics, animation, science education, and now theater and new media. If you go to our website, you can read a long, long list of accolades. But I'm just going to mention a couple of cool ones and one that is actually not on the website, but it's probably my favorite. So for those of you who might be into computer graphics, we have people who are doing Photoshop, graphic design, right? If you've ever used Perlin noise for your textures, that's named after Ken. That algorithm had him, he won an Academy Award for it. I think this is a first that we have an Academy Award winning presenter. It's one of the technical achievement ones, but hey, it's an Academy Award. It's pretty cool. It's pretty cool. But that's not the coolest thing yet. I mean, this is kind of like my favorite thing. He was the system architect for computer-generated animation at the mathematical application group MAGI, right? That's how it was called, MAGI? MAGI. Oh, right. Yes, that was the pun. And it does sound solemn, but it gets cool if I tell you it's the company that did part of the graphics for the movie Tron. So he's been doing computer graphics for a long time. Those light cycles, that was him. But Ken is really a Renaissance man. He's an artist, really, and he has a variety of fields in which he works to really express himself. He's somebody who doesn't quite distinguish between the science and the humanities. It's a rare case of somebody who can still be coding every day and still be going to the theater. We can geek out about movies, plays. Another thing that he's really good at is making computers feel like magic, and you're going to see a bit of that today. His project Chalk Talk, which he's going to tell you more about, allows doodles to come to life. You just have to see it. And also he's working on his HoloJam project, which I'm lucky enough to be a participant in. And he's making it this VR multi-user environment where you can all be in a virtual space together, also low-cost, accessible. And we've been declaiming Shakespeare inside of the VR environment. So as you see, get ready for a really cool presentation. Get ready for all the magic. Please give a round of applause to Ken Perlin.
Thank you. Wow. Thank you. I kept thinking during the previous talk, I love Killer Queen, and I just keep waiting for them to come out with Bohemian Rhapsody. But I will see. So I'm going to start this way back from when I was a little kid. When I was a little kid in the Bronx, when I was 5 and my brother was 7, and we would play with little plastic dinosaurs. These were made by the Marx Plastics companies. They came from, I think they made these in 1963. I think I still have some. Let's see. This is the T-Rex. It's labeled T-Rex on it, in little embossed. And this is the Brontosaurus, and I love the Brontosaurus. My favorite because they're all extinct, but at some point they decided that this had never existed, so it was more extinct than the others. And what's important about this is that we were like little kids, but like all little kids, 2 pieces of plastic, just basically mass-produced, and we would spend hours and hours and hours just making up stories with these things like you did when you were little kids. So there's this weird thing that happens when you're a little kid. You have this superpower that you can take 2 hunks of plastic and you can start, telling stories forever. And then at some point you hit 7 or 8, your adult mind kicks in and you lose it. And then you spend the rest of your life doing things like creating computer graphics and game design where you're trying to build a prosthetic that gets you back to what you lost. And so I'm humbly aware that this is kind of what I've been doing since then. And so things have influenced me. I think that I kind of think of it this way. It's like, this is what I want, is I want something that has this quality of, you know, Harry meets Harold. You know, we want to live in a world where I can think it and it just happens right there. And of course, for a long time, that was just, that was a fantasy. People would write about it. They'd sometimes make movies about it, but some of the elements are starting to show up. So this book came out about 11 years ago. How many people have read Rainbow's End? So it's basically a world that's the canonical 20-something years in the future where everybody's got the contact lenses, and you put on the contact lenses and you can see whatever you want because it's the future. And then the interesting question is not, it's exactly the opposite of Ernest Cline's Ready Player One, in the sense that you're not in a pod somewhere like a refugee from Wall-E, you know, like just like this. You're actually in the world, walking around in your body. It's just you've got the contact lenses, so you and I can have a face-to-face conversation, but we can see whatever we want. So I found it very compelling because unlike some of the other future VR visions, you know, Neo plugging a thing in the back of his head and lying in a tank somewhere, this puts us in our bodies, which I think is where we should be as a species. And so now we're in this interesting sort of transition time. I mean, right now, when you think of VR, you basically, what you're thinking of when you think of VR is this weird kind of, there are these like things that are essentially these boxes that you stick phones into, or they're fancy phone-like things like the Vive, et cetera. And you stick it on your face. And the thing about sticking it on your face is that it is immediately isolating and it's not connecting us from each other. When we think of VR, everything is a variant. Everything is a kind of more or less expensive cardboard variant. And it's really basically Sir David Brewster's stereoscope from 1851, and then somebody said, hey, we can put an iPhone on that, and then the rest is all details. So, but that's an isolating experience. I mean, that stereoscope from 1851, you know, was kind of the predecessor to the Nickelodeon, but we want to get beyond that. And one of the things that's very exciting is that all the big companies, you must know it by now because they're not being as secret as they used to be. I mean, Google and Apple and Facebook and Microsoft and all the other big names that you could think of, Amazon, they're all sort of like realize that there's money in this. So what they're all kind of working on is variations of like this, something like this, where, okay, you just slip on the glasses, maybe it's not the contacts yet, but there's a tiny little 6K by 6K micro display, and then there's some kind of light pipe, and who knows what it's going to exactly be like, but it's going to be cool, and the important thing is it's going to be social, and it's going to be socially invisible, just the way those of you who are wearing glasses, if you don't think about it and you don't look around, you don't remember who's wearing glasses and who's not. So glasses are successful in that they're not about themselves. They're kind of the opposite in a way of Google Glass, in that Google Glass, all you can think about is that, oh, that's a glass hole. But when you think about glasses, you don't think about glasses. And that's where we're going to get. And when we do, we're going to be doing the first approximation to what Werner Vinge was describing. And so I'm sort of concerned about what are we going to do about all of this. So now, for one thing, we're going to be able to just place objects in the world that will be virtual, but we won't think of them as virtual. I mean, everything's virtual. You know, when you go to a restaurant and you look at a menu, all the words are virtual. They only have meaning because we all have shared language. That's just a piece of cardboard with scribbles on it, and then we order from it, and everyone else isn't amazed by that because we all share that superpower that we take for granted of having shared language. But that's a totally virtual thing. And you know, and the same thing with, oh, I'm reading something on my iPhone, or talking to someone on the phone who's invisible and thousands of miles away, and I'm not freaking out about talking to an invisible avatar somewhere else. I'm just like, oh, I'm talking to my friend on the phone. And so this is going to be normal. This is going to be normal. You know, and once you're in this world where, hey, I hold up my hand and there's a creature there and you see it too and it looks at us and it's got a little AI and it's where our games will go, at that point the people who never knew any better are going to just accept that as normal reality. It won't even be a big deal for them. The tragedy about the future, I always think, is that it lasts for about 5 minutes. And then it's like, oh yeah, sure, whatever, pinch to zoom and stuff like that. Get on an airplane and go 30,000 feet in the air and then land in the other part of the world. Sure. I mean, it's like amazing, but it stops being amazing. So to them, none of this is going to be amazing. So that's kind of the setup. Around 2010, we started working on this in our lab about a decade ago. We were all influenced by first, there was a succession of things. There was obviously starting in '92, there was Snow Crash, and then Diamond Age, and then Rainbow's End, and like a bunch of visions. But around 2010 was when the Microsoft Kinect came out, and then we could do this. This is Jonathan Thompson, now works at Google VR. He is a former PhD student in our department. We would do things where people would draw in the air, and you would see on the video behind them the thing that was happening in the future world. And we'd give talks and lectures, and it'd all be real time. And that's when I realized that the physical modality is going to come. We're going to have those hollow glasses or some approximation of them in the next 5 years or whatever. There's billions of dollars being spent by very, very influential people who want to make a lot of money. But what are we going to do about it? And somebody has to think about building content for kids. So what we realized we could do starting around the middle of 2014, this was about a few weeks after I had I refer to it as my religious experience, which is I went out to Seattle and actually saw the prototype of the Vive at Valve, and I was like, okay, I believe now. It wasn't like your crappy DK1 kind of wannabe. It was like good. And so I came back to New York and I said, we have to do this. And so we stuck mocap markers on Gear VRs. So you just use plain old Galaxy Note 4s. In fact, this is exactly the same phone from 2.5 years ago. And then we, back there in the then new mocap room, we got together, we being Luc Dubois and Frank Lance and myself, and we pooled our money and we got a nice 16 camera mocap lab, which when you put these things in it, the significance of it is that the position of where you are is now known by the network and therefore can be sent to your phone, which means we can all share an untethered approximation of that future. We're walking around with our own feet and we can start doing this stuff. We started doing lots and lots of experiments. This is actually in our other lab. We have another mocap lab in our other lab over in Broadway at Washington Square. And everybody collaborates back and forth. There's a third one now at the School of Nursing that Wynn Burleson is running. And I'm going to show you a few of the little things we did. So this is here. So we did a lot of different versions of what we call HoloJam, which is this hollow glasses approximation jamming in real time. This was one we did at SIGGRAPH 2015. This is one we did at the FMX conference in Stuttgart. There should be audio. Let's see. And the network is, everybody's on the phones. There we go. Okay. So basically, we put people in these things, and they're seeing each other as avatars of themselves. We strap on wrist markers and ankle markers, and then we can use inverse kinematics to create avatars that you can't really tell what somebody's gender is or anything else about them. They're just an anonymous version of themselves. But what's really cool is that people would immediately start doing social things together. They started hanging out, they started making up games, they started engaging each other. And you could speak to the person with their own voice, and you can hand them wands to draw in the air. And it was the social collaborative nature of it. This was around the time we started really becoming convinced that, I think the way we finally put it is that the holodeck is other people. What you really care about when you go into a shared experience, which I guess seems obvious when you think about it, is not just your experience, but even if you play a game by yourself, you get to tell other people about it and discuss it with them. And it's that connection that is the powerful part. So that's when we really started rethinking all this stuff. And I'm going to show you one more thing because it was so cool. About a year ago, we got together and decided in that room there to do an all-day experience where so those of you who know about the Mexican Day of the Dead know that, November 1st, it's a happy occasion because it's when the spirits all celebrate that we remember them. And so it's not dark and despairing, it's fun, it's a party. And so we decided we wanted to create that. What would it be like to be one of the spirits hanging out? Now, one of the tricky things, and the artist who does all these things, who works in our team, was originally at ITP, and then he took my graphics class, is David Lobser, who's a brilliant artist. And a lot of the things he tries to do is how can you get very high quality experiences running on these phones? So he doesn't have the high-end PC of a Vive. So all the graphics you see can run on a smartphone. And so this was our take of the Mexican Day of the Dead. And here we went really, really minimal in the sense we just gave you a headset and two controllers, and we put you into the world and you started doing stuff together. So let's see, where is it? Dia de los Holos, okay. Louder. This is all phone graphics. So they're all seeing each other in this as spirits in this world. With lots of other spirits that are virtual, hanging around and dancing and celebrating with them. And when you see things like fans, you actually can walk up to them and see them and they blow air at you. And there's all kinds of little haptic things we put in there and sweeten the experience. So yeah, so that was pretty awesome. It's just so I just work with talented people. It's really wonderful. So David also picked the music, so I think you get a little bit of his sensibility there. You get what he's like. But what I want to talk about is then, for me, for the last 3 years, since I would say about the autumn of 2013, I've been tackling this problem of, now that we know that this is coming, how do we design a language for it? So I started this parallel development all in JavaScript and HTML5 so it could run on the web, because I figured these things are going to run web apps. And all that was coming, and so sure enough it has. And so I started creating what I thought would be an interesting, like, what's the grammar of drawing in the air? And that's what I want to spend most of the rest of the time talking to you about, which is this notion that when I draw something in the air between us, the thing that I draw, we have computers, so I should be able to draw things. And just as when I say the word elephant, you don't have to look it up in a dictionary, we all have the word elephant in our shared vocabulary. In a mature version of this, little kids will be able to draw things in the air, and the computer kind of knows, that's a pendulum. So it has the behavior of a pendulum. And so if I could draw another object, which is, this is an object that you find out about things, and I could connect them together, so I drew this and I drew that, and it's, now, by the way, the concept isn't new. The idea of a visual programming language dates back to Ivan Sutherland's older brother, Bert Sutherland, who did his Ph.D. at MIT, I think he submitted in January 1966. So it's been over half a century that somebody made the first program. But the interesting about this is that I'm trying to say, unlike, say, Max MSP, unlike, some of these things, I want this to be real-time, conversational. We don't think about it. Low cognitive load. This is all about, we're just hanging out and stuff's happening. So what interests me about this is that you can start thinking about things in the world as being physical but also being information objects. Like if I draw a chair is a physical object, but it's also an information object because somebody might sit on that chair, and in a sort of an Internet of Things, you might want to say, let me describe visually, and maybe my design is just sketching something out, and then the computer goes and does what I say. I say, okay, so we also have, maybe we have, fans in the world, okay, and there's a relationship between a fan and a chair, in the sense that if I connect the fan to the chair, now the fan knows about the chair, et cetera, et cetera. So if somebody, sits on the chair, the fan starts going. And we should be able to have that kind of simple conversational way of talking about things. Now, I use this stuff in my research, and I do use it in my teaching. The very first thing I ever did as a pixel shader was, I think, August 2013. I finally jumped in and started embracing abandoned Java, and because Oracle insisted that we abandon Java. And so then I embraced JavaScript, I embraced WebGL, I just went for it, and I just totally retooled and started teaching using that stuff. And the first thing I did was I re-implemented some of my procedural textures that Clara talked about from long before. And so this is the very first procedural texture I ever made, was kind of a procedural planet. And this is all being done in a fragment shader. This isn't really a 3D object. This is actually, you can see it's a 2D object, totally fake. It's actually two triangles, and I'm just running something on each pixel. But the nice thing about this is when I teach, because I have a visual language that's conversational, and I can just do stuff in any order, and then somebody asks a question in my graphics class, and then at that moment, because I have a language, I can just pull this stuff up, and I can say, oh, let's look at the vertex shader, let's look at the fragment shader that's running on the hardware right now, and I can go in and I can say, suppose we make a change, and I'm changing the color or something, or I could change the shape or anything, and this, except for the noise function, which I have in a library, it's about 30 lines of code, this is the entire design space for this planet. It's all there, like the atmosphere, the movement, everything, and because shader languages are a beautiful thing. So that notion that I can just do these things is, I think, propelling me to then think about what happens between you and me. Well, this stuff is going to be in the air in 5 years. It's going to be floating between us. Kids will start learning this stuff. How are they going to have conversations with each other? Things that we now think of as, oh, I have to go off and SketchUp is really easy to use, but it's not performative. I have to go off into my own space and make something, even with something as simple to use as SketchUp, because it was never designed to be part of a real-time conversation. Sort of the difference between I'm composing music or I'm sitting and playing on a piano, and I want to understand that new space of jazz improvisation that's going to happen visually, that is going to be enabled, because it's just going to be here. It's not going to be here. Wait, I'm getting a text. It's going to be here. And so, for example, let's take some scenarios. Suppose you and I are having a conversation, and it's about we're trying to design an object, and we want the object to be sitting on the chair between us. So this in Chalk Talk is this is the glyph for I'm going to design an object on a virtual lathe. So now it's expecting me to just go ahead and give the profile, because I've done that much. So here I'm going to draw a profile of an object, and then now I have just in real time designed this object. Now, just to put this in context, let's think about this. In the future, I will just do this by drawing in the air. You and I, just like that little gumball machine, we're going to think of that object as there. We're going to be able to say, oh, let me just give it a material. It's a kind of clay-like thing. Now, one of the non-obvious things is if you got the glasses that let you see things that aren't there, they also let you not see things that are there. Like right now, I mean, there's plumbing behind the walls and electrical wiring. I know they're there, but I don't care. I just know that I plug this thing in, stuff happens. That's going to start happening. There's going to be robots running around. And Werner Vinge talked about this in Rainbow's End in 2005. And they're going to be delivering things to us, and we won't think about it. So here is like an early experiment done in our lab by Jian Hu, one of our Ph.D. students, where she just makes a gesture, and this little robot comes toward her, and whatever she does is basically mapped to her gestures. She can make go this, she can make do that, and we could actually think, oh, I see an object that's like way across the room there, and I make a gesture, and it flies toward me, and actually what happened was a little robot just brought it from here to there, and I could pick it up. So we can start doing these haptic servers. Now, if you think about it that way, then we make this thing, and we go out to lunch, and 3D printer starts printing. The robot comes back. Nobody ever sees it because we make the robots invisible, because we can show you things or not show you things. And we come back, and we know that when we come back from lunch, this object that we made will still be there in the same spot, except it'll be fully developed. will be able to pick it up. But it started to exist the moment we drew it. And that's going to be a different way of thinking that's very fundamental, but it's going to seem perfectly normal to those kids in that picture. So now you see me do this, you know the same language I do, so you say, I really like that, but I have some design ideas. So you draw a little curve in the air and you attach it to this thing, and you start saying, I think this is what it should be looking like. By the way, what's going on behind the screens here, for the scene here, for those of you who are like interested in the guts of it, is this is actually spitting out a closure, which is a function plus data that this thing knows how to evaluate. So this spline object is sending a procedural recipe over to this guy, and he's saying, oh, thank you, that's a procedural recipe. I know that I'm going to use that in the surface of revolution. So we start doing stuff like that. Maybe you've drawn this cool thing, and I look at that and I say, hey, I really like the curve you drew, but actually I don't want to use it for this vase. I want to use it for this little animated character that I've been creating, because I've been making a little animated character and I've been looking for a really cool movement for it. So, and I wanted to go through a kind of a looping movement, and what you've just done is really, really great. So, so now what's happening is the same procedural object for design, which is the curve, is being used not for a shape, but it's being used for designing an animation in real time. And this is stuff we're used to. We've done things like, we use tools like this, except we don't use them in our casual discourse. And that's what's going to change. The nature of those tools is going to change. It's going to be going from the compositional tools to the performative tools. The affordances will be very, very different. The learning curves will be very different. The shared cultural understandings will be very different. How are we doing with time? 5 minutes, okay, great. So I just wanted to then mention that, this you can do this with physical objects, you can do this with virtual objects. There are objects that I want to interact with that I cannot interact with in the world around me. I want to be able to say, hey, I just want to draw a thing in the air, and it's, sure, it could be a cube, but it could also be a hypercube. And now I have a 4-dimensional object, because I love hypercubes. I'm into, me and Vi Hart, we're both like, we bond in the 4th dimension. And so that will be something we can take for granted, that kids will be, oh, let me play with a 4D object, and I can look around it, and it just floats in the air and exists. And I'm going to give you one serious example. So this is a kind of an excerpt from a lesson that when I teach computer graphics now for the last 3 years, I've been using ChalkTalk to teach graphics. And the nice thing about it is that when you draw on a blackboard, you have this sort of sequence, the storytelling, the drama, oh, and then I do this, but then nothing moves. When you just bring up a computer program, oh, here's the computer doing something, but it's completely divorced from your storytelling. But if you put programming together with drawing, now you can start telling stories, and at the right moment, the computer says, yeah, it's really running that. So I'm going to give you one little example for a topic that is traditionally quite difficult for people to understand when they're first taking graphics, which is the idea of coordinate systems. So coordinate system can be 2D, but of course it gets more interesting if it's 3D, and if you draw any object, that object can exist. You could drop it into a coordinate system, and that means that the promise is that you'll be able to do transformations, and any properties that that object has are going to move over to its view in that coordinate system. So this is an image of this object in a kind of a 3D sort of mirror of sorts. Now I can start talking about the real good stuff, which is using 4x4 matrices to do coordinate transformations. So people often get stuck on 4x4 matrices because you can't connect the picture of them with what they do. It's really just the space of all possible linear transformations, and I have just this glyph for this. And so this is the structure of a matrix. In general, that's the identity matrix. If you change along the right column, that's a translation matrix. If you change just that middle thing there, that's rotation about the x-axis. And the reason it's rotation about the x-axis is because y and z change, but not x. In fact, we can now demonstrate that to them. We can say, okay, we'll just attach a slider to this thing. And now that we've attached a slider to it, we get numbers. And because it's a visual language, things are nouns, but they're also verbs. So we can use this as an operation. And now I can start say, oh, but it doesn't rotate very fast, but because this is also an object that I can interact with, so I can say, oh, let's just change that. And it's, the kind of this wonderful Brett Victor kind of like, let's just change the numbers on things. And that's, so now you can actually see rotation about about the x-axis does not change the x value. It's very clear. If you rotate about the y-axis, then sure enough, you can see the math, you can see what it does, and it doesn't change the y-axis. It only changes the z and the x. But because everything can be a noun or a verb, we can bring in concepts and make them very explicit. So for example, we can bring in a concept of time. We all know what time is. But time is both a noun and a verb, and we can say, oh, let's just drop time in here. And if we drop time in here, now it's a rate controller. And so that's rotating about this. This is rotating about the z-axis. And suddenly, people can start, they could jump in and play with it themselves, and they can start seeing the math being acted out. Now, because of the decision to do all of this in HTML5, so this is all JavaScript. I started using 3.js, but then I ended up writing my own modeler because I wanted to have control over it. And so all of this stuff would run on smartphones and does run on smartphones. And this is all just everything. The text, everything is part of a 3D scene. In fact, you could just look at it in a stereo viewer, and it's just running in a canvas. I'm doing all this stuff with fragment and vertex shaders. So just to kind of, just to wrap up a little bit, I just want to talk about one or two more things, which is that my dream, my interest in this, and probably comes from playing with these guys when I was 5 years old, is that I'm really interested in bringing characters to life. I want to be able to draw a character, and the fact that I drew that character means that character is now in my world. That character is sitting on a table somewhere. So, I can dress it up, I can color it, I can, give it behaviors and things, and then I can do things like, oh, my character dances, or it walks, or something. And except it's not in some abstract space. In the future, it's floating between us, and it has these kinds of personalities and ways of dealing with things. And I think that that's like really important. And they don't have to be fancy characters. They could be simple characters. So for example, you could imagine a situation where I draw a character and the computer kind of understands like animated characters, and it gets it, and knows that people are very interested in animated characters. And of course, one of the most important thing about animated characters is not that we are interested in them. The most important thing about interactive characters is that they are interested in us. So this guy is totally fascinated by my cursor. And the reason he's looking at it with one eye, the reason he's fascinated by it is that he's actually quite ticklish. There we go. And then of course, eventually they leave us. So I think I'm out of time, but I can bring up some new stuff during the questions, and so like room scale stuff. So questions. What? Oh, sit down? Sure. Okay.
And there's a microphone back there.
Okay, microphone, right? Okay.
I told you
Where's the microphone? Oh, there it is. Got it.
Hello. I told you there was going to be magic. All right, so we have a question back there. Hey, Ivan.
Can you tell us about room scale stuff?
Yeah, so here's the thing, is that this whole VR being isolating thing is kind of annoying. And so the way I think of it now is that VR and AR just, VR seems to...
Is it on?
Oh, sorry. Hold on.
It's on.
Yeah, it's on. VR seems to split into these two different things. There's either mobile, which is basically, even if it's Daydream, so it's really fancy, it's still cardboard. I'm like in one disembodied place and I'm looking around. Or there is room scale, and then it's costs a lot of money. There is wires trailing. I mean, Vive is successful, but there's only 100 and something thousand units. Meanwhile, there's billions of these. So obviously the high-end, hi-fi kind of blah, blah, blah is not going to be certainly not going to be what people in India are going to be using. So I'm really interested in this. Now the Tango phones are eventually coming out. I don't want to wait for them. But the cool thing is, like, this is something that I got for $15 on Amazon Prime. Arrived the next day, sure enough. And if I told you I can run little VR things on my phone, so I could just go to a web page on my phone. Oh, something political. Why am I obsessed about political things? Anyway, so let's see. Where is it? Hold on. Let's see. Sorry, I just need to get to a URL. There it is. Get to a URL. Hello, do I have the web? Is the web happening here? Maybe if I'm not on the web, then it's not going to work. Okay, yeah, there you go. So this is like a stupid little hello world that I made, where it's basically just a stereo scene. You know, I look around it and stuff. Oh man! All right, I give up. There's a 3D scene somewhere in there, but we're not going to see it because we saw it briefly. Hold on. Oh, there you go. Okay. There you go. So it's just using the gyroscope in my phone. It's very simple. You know, I could actually go to URL and see the live stuff that's happening in our mocap lab on Broadway right now. It's all being sent over HTML. It's over the web. We're making it really accessible. But the thing is, this thing right here. Put this thing here. And it's basically, I look around this thing and I'm basically seeing what Google Cardboard would show me, except it's better because I can touch the screen. And also I can see Clara next to me, so that's more socially engaging. So it's kind of halfway between VR. You get the advantages of VR, but also some of the social engagement of AR. But the problem is it's still a cardboard model. And so we don't want to wait for those stupid Tango phones to come out, and then they're only going to be for high end anyway. So we're rolling our own. What we're doing is you take a camera, it could be your webcam on your...
One of them just came out last week. The Tango phone.
Oh, I know. I know. But I don't want to wait for everyone to have them. I want you to use the phone in your pocket right now. I mean, we have Tango phones in our lab, and they're really cool, and they're amazing. They're a little too much latency, unfortunately. You know, still 100 millisecond latency, which is okay for AR, but not okay for VR, because they have to do all the computation. So what we decided is you take even if you go high-end, you take a $30 phone, a $30 camera. Let's see. Do this. Put this onto here. And then flip that there. And then, actually, we're really going to run it in IR, but I'm using visual so you can get it. And you go like this, and you look around, and basically everybody who is wearing these things, no matter where they look, no matter what direction they look, they're now in the same space together. Because we want everyone to be able to do this super on the cheap. So we're writing server software and support for both HTML5 and Unity, and it all runs on any phone. It doesn't matter, and we're rushing to get dev kits out to people so they can start playing with them on December 15th. And then Chalk Talk is one of the things that you'll be able to do, and we won't have to wait until everybody upgrades to a Tango phone in order to start understanding what content development is. Okay.
Okay. One hand back there.
What about Magic Leap?
So what about Magic Leap?
Well, Magic Leap is awesome, and I'm waiting for it. I think it's one of those things that's where the world is going. It's one of the things that motivates me. It's that it's very clear. I mean, Google is backing Magic Leap, and Mark Zuckerberg has indicated that they're doing something at Facebook, which is roughly equivalent. In other words, the AR glasses. Probably the AR glasses are initially going to be, there's still going to be a big brick in your pocket, but the brick is going to be for power communication and GPU, and then there's going to be a lightweight thing here, and they're going to somehow communicate with each other. But that's going to be the form factor, probably. But so the significance of the possibility of Magic Leap, it's hard to know what the reality is they're not just focusing on AR, they're also focusing, I hope, on AI and object recognition. So, and that's, you put those two things together, I walk around the world and my computer system knows what's going on around me. It knows that's a chair, it knows that I'm going into a subway. And then you start replacing the signs in the external world by the signs that we're all wearing, except now they're contextualized. It's like, imagine having Google Street View or the parts of it you want as you walk around, and it's figuring things out. I think the vision could be very positive.
Okay, we had a question over there. Yes.
You mentioned that you're making a new vocabulary. You mentioned the term information object. You're describing like your chair. Could you explain that?
Well,
So explain,
yeah,
we need to record the question. So,
go ahead.
yeah, so he wants to know what the definition of information object is. What do you refer by that?
Well, I think that we think of a chair as being something real, but in fact, in nature, we don't find them. We actually have to manufacture them. And, you know, they fold, and they have all these nice multiple materials, and they're very fancy, but we take them for granted. But they're information objects because we made them using technical means to serve the purposes. They don't just serve the purpose of you sit in a chair, you don't fall to the ground, which is very important, but also that they also have a sort of social significance, like chairs of a certain kind sort of are there's a certain kind of gathering this is with a precise amount of formality or informality and amount of space for everybody. So everything we make, clothing is an information object. Clothing is one of the earliest forms of virtual reality. You're not actually seeing each other's bodies. And you're not seeing each other's bodies is because we decided centuries and centuries ago to cover everyone else's body with essentially a completely artificial virtual reality. The fact that it's pre-computer doesn't change the nature that clothing at this point, and nobody's wearing the clothes they're wearing right now because they're hot or cold, because we also have climate control. They're wearing it for social signaling. And so I think it's important to understand that every object we make is an information object because we're using it to communicate with each other.
So just as a segue to this, in ChalkTalk, part of the key is not only that it would ship with a series of objects that you've already made, but that users should come up and need to come up with their own vocabulary for ChalkTalk so that they can express themselves in a way.
It's an interesting question, and I think it's an important research question. How will these languages develop? I've been cheating in that I mostly teach computer graphics, so I've just been developing visuals that make sense for me teaching computer graphics. But I suspect that the real achievement is not going to be when we can visually describe technical things or manufacturing or logical things. It's going to be when little kids up to 7-year-olds, they have enough access to the language creation, again, some of that AI stuff, when a bunch of them gesture this way and then the system says, oh, they're all gesturing this way to mean something, the language starts evolving because little kids all understand it, and then natural language itself starts becoming enhanced because it has a visual component. That's going to take some research that involves AI research that beyond the stuff that I've done so far, but I'm hopefully trying to set the seeds for it.
Or maybe just come up with a set of emojis that work for ChalkTalk.
Well, one thing to remember is that one of the powerful things about natural language is that little kids develop. We don't develop natural language. Little kids do. Only little kids have the power to do that. And the reason is that basically, if it's not understandable by a small child, it never gets into the language, period. Like, that's how it happens. But I'm not going to too much detail into that, but the point is what they end up doing is they start combining things into recombinatorial grammars. And emojis aren't powerful enough by themselves, but they could be used as part of a natural language system. But it would have to be more than emojis.
Okay. We have one question here in the first row.
So you described earlier that language was another early form of virtual reality. Why do you see the development of these natural languages as drawing and literal, like pictorial, instead of being maybe just lingual?
I don't know. I'm hoping that other people...
We need to record the question.
Oh, sorry.
So the question is, are we going to develop a vocabulary of visual language rather than just verbal?
Yeah, well, I think that it doesn't have to be literal. Clearly, those arrows between things are representing a process, and I think that there needs to be a lot of abstractions. I tend to develop the things that I develop partly because when I try to explain this to people, even the more abstract things that I've developed, people don't understand what they are. So just telling the story of what's possible, it's easier to use the concrete in just giving a talk about things. So that's a constraint right there, which would not be a constraint if people were sort of future literate. I also want to say that the ability to learn natural language, which is the #1 great power-up of humanity, is not a technology, it's an instinct. This was the great gift we were handed by our evolution, and then everything else is what we've done with it now that we actually have the power to develop these cultures that come out of natural language. So there's a distinction between natural language and all the other stuff.
Okay, we have the lady back there. Yes, you.
Do you think this could be used for evil in any way?
Oh, how can this be used for evil? That's a great question.
Well, somebody once said that technology is neither good nor bad nor value neutral. I completely concur that, if you make it, you're responsible for it. And same technology, of a book, hey, Uncle Tom's Cabin, which led to consciousness raising and helped lead to the end of slavery, and Mein Kampf, it's the same technology. So I think that, as in the immortal words of, all right, does anybody remember what Spider-Man's uncle said? So yeah, that.
Okay, we have one last question. Was it back there? No, 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 back here. Okay, last question.
I had a question about your talk thing where you were making assumptions about what things mean in terms of the processes when you're linking two things together.
Yeah.
And I know that Stephen Wolfram has spent a lot of time trying to kind of put functions that combine and things, understand how other things work, and Wolfram Alpha and all those things are kind of ways of kind of encoding what it means for a picture to go into a function and all those things. Have you ever considered like what kind of assumptions you're making about those kind of transformations, or whether you'd use something like the Wolfram Alpha stuff to make those assumptions?
Okay, so the question is, would you consider doing something like Wolfram Alpha for Chalk Talk?
Well, he's clearly put a lot of work and a thought into what he's doing, and I've talked to him about it. And I think that the key is that everything is good for something. And Chalk Talk is really, really focusing on minimizing cognitive load during a real-time conversation between people, and it's trying to get to that goal. And I think he's trying to get to a different goal. So because he's trying to get to a different goal, his correct design decisions would be different from Chalk Talk's correct design decisions. So there'll be some intersection, but also necessarily some difference.
All right, so that was the last question. I want to remind everybody that now it's lunch until 2:30, right? Am I right, 2:30? So please, let's give a round of applause for Ken. Thank you so much.